Time feels familiar. You glance at your watch. You sense yourself aging. You recall yesterday and anticipate tomorrow. It appears self-evident, the most natural phenomenon imaginable. But that perception isn't time itself. It is merely a sensation, a neurological illusion your brain constructs. Most people carry around this romantic notion that time resembles a river, imagining it flows and carries you from past through present toward future. You believe it moves, but here is the fundamental flaw in that elegant metaphor. If time were a river, at what rate would it flow? 1 second per second. That statement is circular nonsense. Equivalent to declaring a table measures 1 table in length, it reveals absolutely nothing about reality's true nature. The actual truth is far stranger, far more mechanical, and frankly far less poetic than any flowing stream. Time doesn't flow. Time exerts no force upon you, and if you believe you comprehend how time operates simply because you can mentally count seconds, you're about to face a profound shock. Let's begin with what occurs inside your brain, because that is where the misunderstanding originates. You assume your internal clock functions as a reliable instrument. It doesn't. It is a chaotic jumble of translation mechanisms. Consider this straightforward experiment. Attempt counting to 60 seconds mentally. Just sit and count. 1, 2, 3. You think you're measuring time. But what you're actually doing is executing a highly specific, highly personal program. Some people, when counting, hear an internal voice. They're literally speaking to themselves, subvocalizing 1, 2, 3. If someone interrupts and asks them to speak aloud, they lose their count. The mechanism breaks down. But others, and this is where it becomes fascinating, hear no voice whatsoever. They visualize images. They might see a tape measure with numbers scrolling past like a ticker. Click, click, click. If you employ that visual tape measure system, you can actually read a newspaper or review a shopping list while counting time. You can organize your laundry, examine fabric patterns, and still maintain that mental tape measure clicking flawlessly. But the person counting with a voice cannot read a single word without losing their temporal tracking. This reveals something fundamental. What you experience as time's passage is merely a mental construction, a pattern, matching exercise your brain performs. It varies dramatically between individuals. It is not a universal constant. It is a biological hallucination. So when discussing physics, when discussing the universe, we must discard your brain's testimony. We must stop discussing how it feels and start examining what it actually is. In physics, we must be operational. That means we don't ask what is time's essence, because that is a question for philosophers who enjoy debating over coffee. We ask how do we measure it, and the answer is almost disappointingly straightforward. Time is simply a method of ordering events. That is all. It is a labeling system. Imagine you have a deck of cards. You arrange them in a row. You can state the jack precedes the queen, and the king follows the queen. The table isn't flowing. The order is simply a structural property of how the cards are positioned. Time is the table. Events are the cards. When we say time passes, we're simply reading the cards from left to right. This brings us to the biggest misconception everyone makes. You think time is a container. You imagine the universe is a large empty box, and time is a clock on that box's wall ticking away. Even if the box is empty, you think that if we removed all stars, all planets, all atoms, and all light, time would continue ticking. Tick, tick, tick. Wrong. This is the Newtonian perspective, and it is obsolete. Time is not a background stage. Time is a measure of change. If absolutely nothing in the universe changes, no atoms vibrate, no light moves, no energy shifts, then time stops. It ceases to have meaning. You cannot define a second without a physical process to mark it. A swinging pendulum, a vibrating quartz crystal, an oscillating cesium atom. Time is not separate from the universe's contents. Time is a property of the contents. This is where your intuition resists. You say, okay, but surely time acts on things. Time makes me age. Time causes milk to spoil. No, it doesn't. This is a linguistic trap. Time is not an agent. Time has no hands. It doesn't reach into the refrigerator and sour your milk. Bacteria do that. Chemical reactions do that. Entropy does that. Time is simply the bookkeeping system we use to track the rate at which those reactions occur. Saying time did, it is like saying inches constructed the house. Inches didn't construct anything. Carpenters did. Inches simply tell you where the walls are positioned. Time is the ruler, not the builder. Let's extend this ruler analogy further, because this is where things become genuinely strange. If time is simply a ruler we use to measure the distance between events, what happens if the ruler itself is flexible? This isn't science fiction. This is measurable fact. We used to think that a second was a second anywhere in the universe. If you had a clock on Earth and a clock on Mars, they would tick in perfect synchronization. It feels obvious, it feels correct, and it is completely false. The rate at which clocks tick depends on where they are and how fast they're moving. This is not a mechanical failure of the clock. It is a fundamental feature of reality. Imagine you're driving a car across a giant flat sheet of paper. You can drive north or you can drive east. If you drive purely north, you're making maximum progress in the northward direction. But if you turn the steering wheel and start driving northeast, you're dividing your speed. You're moving somewhat north and somewhat east. You aren't traveling north as quickly as you were before because you diverted some of that motion to the east. Now replace north with time and east with space. This is the essence of relativity. You are always moving through the universe at a constant speed, but that motion is distributed between space and time. If you sit perfectly still in your chair, you're dedicating all your motion to moving through time. You're traveling into the future at maximum speed, 1 second per second. But the moment you stand up and walk or get in a rocket and fly, you're diverting some of that motion into space. You're moving through space, which means you must, mathematically must, move slower through time. Your clock slows down. Your aging slows down. You aren't breaking the machine. If you could move at the speed of light, which is the maximum speed limit of the universe, you would be using 100% of your motion for space. You would have zero motion remaining for time. For a photon of light, time does not pass. It is born and absorbed in the same instant from its own perspective. The universe is frozen. Now you might be thinking, well, I don't feel my watch slowing down when I run for the bus. Of course not. You're too slow. You're a biological snail. The effects are minuscule at human speeds, but they're real. We have to program satellites with this mathematics. GPS satellites are moving fast, so their time is different from your time. We literally have to adjust their clocks. If we didn't, your GPS would be off by miles within a day. There is another aspect of time that deceives us, and it returns to that counting problem. The concept of pattern recognition. We perceive time as having a direction. An arrow. Past is fixed. Future is open. You can remember breakfast, but you can't remember dinner. Why? If physics equations work forwards and backwards, and most of them do, why can't we remember the future? If you film a planet orbiting a star and play it backward, it looks perfectly fine. It obeys all the laws of gravity. But if you film an egg falling on the floor and breaking, and then play it backward, everyone knows it is fake. The yellow yolk doesn't leap off the floor, reassemble itself into a sphere, and seal itself inside a shell. Here is the secret. This isn't about time itself. It is about probability. It is about disorder. It is much, much easier to break an egg than to construct one. There are a billion ways for an egg to be broken. Scattered here, splattered there, shell in 3 pieces, shell in 1,000 pieces. But there is only one specific arrangement where the egg is whole. So as things move and interact, they naturally transition from the organized state. Few options to the disorganized state. Many options, we call this entropy. And this is the only reason you feel an arrow of time. You're watching the universe shuffle the deck of cards. You started with a perfectly ordered deck, and every second that ticks by is simply the universe shuffling it somewhat more. You can't unshuffle the deck simply by wishing. This means that your sensation of time flowing is actually just your brain registering the increase of disorder in the universe. You're a disorder detector. When you distinguish the past from the future, you're really just distinguishing less chaotic from more chaotic. If the universe were in a state of maximum disorder, maximum entropy, where everything was evenly distributed and nothing interesting was occurring, your brain wouldn't be able to tell the past from the future. There would be no egg to break. There would be no memory to form. In a thermal equilibrium universe, the arrow of time vanishes. So let's return to those people counting in their heads, the ones seeing the tape measure versus the ones hearing the voice. They're both struggling to impose a rigid linear structure on a universe that is actually much more flexible. We construct these mental models, these counting machines, because we need to survive. We need to know when the predator is approaching or when the harvest is ready. We evolved to track duration, but we did not evolve to understand the dimension of time. Our brains are efficient, not accurate. We focus on the now because that is where we exist. But in physics, now is a very slippery concept. If you and I are standing next to each other, our now is effectively the same. But if you're on a planet 1,000,000 light years away and you start walking away from me, your definition of now slices through the universe at a different angle than mine. What you consider to be happening right now might be in my future. What I consider right now might be in your past. There is no universal now that covers the whole universe like a blanket. The universe is a block of events, a 4-dimensional loaf of bread. And how you slice that loaf depends on how fast you're moving. This is difficult to grasp. It feels wrong. It feels like I'm telling you that up is down. But that is because you're trying to translate the high-level language of the universe into the low-level language of your biology. You're trying to count socks when you should be measuring light beams. When you try to force the universe to fit your intuition, you get confusion. You get paradoxes. But when you release what you think time is, when you stop trying to count it like a pile of laundry and start measuring it like a dimension of space, suddenly the equations work. Suddenly the universe makes sense. We're not finished, because even if we accept that time is a dimension and that it stretches and compresses with speed, there is a much deeper question lurking at the bottom of the well. We talked about measuring time, and we talked about the arrow of disorder, but we haven't talked about the beginning. If time is a measure of change, what happens when you run the movie backward all the way to the first frame? If the universe is expanding and we rewind it, it gets smaller and smaller, hotter and hotter. Eventually, you reach a point where the laws of physics themselves start to melt. You see, all our clocks, our atoms, our planets, our light beams, they exist inside the universe. But if the universe itself was born in a moment we call the Big Bang, does it make sense to ask what happened before that? This is the ultimate test of your new definition of time. If time is simply a way of ordering events inside the universe, then asking what happened before the universe might be as nonsensical as asking what is north of the North Pole. It sounds like a valid question grammatically, but geometrically it is gibberish. There is no north of the North Pole. There may be no time before time began. And yet we still have that nagging feeling, that internal counter, that voice counting 1, 2, 3. We desperately want the universe to have a backstory. We want a timeline that stretches back forever. It is difficult to accept that the tape measure might simply start, that the counting machine had an on switch. This creates a friction between our psychology and our cosmology. We are finite beings attempting to comprehend the infinite using tools made of meat and electricity. It is a wonder we understand anything at all. Consider the patterns again. The person who sees the tape measure in their head can count while reading because they're using different circuits, visual versus verbal. Physics is the same. Classical mechanics was the verbal counting. It worked for day-to-day situations. Relativity is the visual tape measure. It allows us to process complex patterns that the old method couldn't handle. We're constantly upgrading our mental software to match the hardware of reality, and the upgrade process is painful. It requires discarding ideas we cherish, like the river of time. But here is the beautiful part. Even though your intuition is incorrect, even though your internal clock is a biological hack, and even though time is a flexible, relative, bendable dimension rather than a strict metronome, it still functions for you. You can still boil an egg. You can still meet a friend for coffee at 2 p.m. The strangeness of relativity is hidden beneath the surface. You don't need to understand the combustion engine to drive the car, and you don't need to understand space-time metrics to live your life. But isn't it better to know? Isn't it better to know that the engine is there? This brings us back to that strange experiment with the counting. Remember the difference between the person who hears numbers and the person who sees them. This is not simply a party trick. It reveals a profound gap in how we understand the universe. When two people talk to each other about something complex, like time or relativity or love, they think they're speaking the same language. They nod, they agree, they say, "I understand." But what is really happening? Invisible translation scheme. You take the words I say and convert them into your private internal imagery, which might be completely different from mine. I say 1 minute, and I see a clock face. You hear a voice saying 60 seconds. We arrive at the same answer, so we think we agree. But the machinery inside is totally alien. This matters for physics because it exposes the fragility of common sense. Common sense is simply the collection of prejudices you acquired by age 18. It is built on your specific internal imagery. If your mental image of time is a tape with numbers on it, you'll struggle to understand how time can bend. If your mental image is a voice counting, you'll struggle to understand how time can be spatial. When we try to teach you about the quantum vacuum or the curvature of space-time, we aren't simply giving you new facts. We're asking you to delete your operating system. We're asking you to throw away the tape measure and silence the voice. And that is why it feels so difficult. That is why your brain rejects it. You aren't simply learning. You're translating against the grain of your own biology.